And recording. Hello everyone. Hello Wallace, Trent, Somsi, Simanga, Sabah, Said, Ricky. What do I call you, Cody? Condi. Always forget your name. Hello Condi, Pascal, Olowatubi, Marionette, Jan underscore M, Mititi, Harp, Cindy, Morba, Bello. Hello everyone. So today we have three LeetCode as always. So the first one gonna be majority element, then we're gonna do add binary, then diameter of binary tree. So we are close to finish week 6. We have this tree. Tomorrow we're gonna do this tree, and then we're gonna jump to next week where the LeetCode is gonna be a bit hard. So let's see how we're gonna solve this one today. Let's start with the first one. Which one? Majority element. So this one, and let's read it, see how we're gonna solve it. Okay, so majority element, given an array nums of size n, return the majority element. The majority element is the element that appear more than n divided by 2 times. You may assume that the majority element exists in the array. You might assume that the majority element always exists in the array. Okay. Who did understand? Who did not understand? Let's check this example. Nums have 3, 2, 3. The majority element is 3. So I guess it is the one that has majority in the array. This one 2, 2, 2, 2, 1, 1, 1, 1, 2, 2. So 2 is 4 times, 1 is 3, so 2. Okay, and there is one rule here is you may assume that the majority element exists in the array. Okay, let's take this, see how we can solve it. First, before we solve it, let's see.
Sorry, and don't forget the condition as well that says n over 2 times, n divided by 2 times.
This one, right? In yeah. Okay, so if we have an array like this and it have like x element, let's say x, z, y, they're gonna be always some elements of this that are n minus 2 times. So like the length of the array, for example 5, let's say a element a, let's say 6 divided by 2 is 3. So they're gonna be elements that's always more than 3, right? So 4 elements, so one of them is gonna be x. So the problem is like we have an array. This array have element like let's say x, and this is x, and this element y, this element a. We need to find the majority element. Which element is like taking the majority? With one rule is there are gonna be always some element here that is more than the half of array. So I already see some solution in chat. Counter, turn the max. Okay, but let's see before we go to solution. Who did not understand the problem? Don't be shy. Can just write in chat. Can you explain again? I will explain it. Okay. So let's try to solve this one. So we have some solution in chat. Let's see how it works. Collection counter, so you're gonna counter the array and then the max hash. So what this gonna do is it's gonna create a hash map, and then it's gonna put first element 2, and then it's gonna put how many? 4, and then it's gonna put element 1, it's gonna put 3, then the max gonna return the bigger number here. Is that correct? I think
the max hash returns the key with the maximum value. I think something like that.
Okay, but this is a bit complex. Let's try to do it simple. Sorted. Okay, this is a good solution too. Sorted. So we're gonna sort the numbers, then we're gonna return the middle one. Yes, this is smart. So because we know that's one of them gonna be always majority, so if we sort them, it's gonna be like 1 1 1 2 2 2 2. So if we split it in the middle, we're gonna always, this is gonna be always the majority, right? Because we have always n minus 2. One element is always gonna be greater than
satisfy every case.
Can you repeat?
Satisfy every? I mean, is it going to satisfy every test case? This particular one, is it going to satisfy everything?
I think so, yeah. Because if there is always some element that exceed the limit of the middle, if we take always the middle one, it's gonna be always the majority, right?
Yeah, that makes sense. Yeah.
Personally, I'm not getting your explanation. How, when you divide the length by 2, what are you returning?
I'm gonna return this array. I'm gonna go looking for the length nums minus 2, so it's gonna give me the index of this element. Because if the length, let me see, length names, which is how much gonna be? It's gonna be the 6. So the length is 6, and is split it divided to 2. It's gonna be 3. So the index 3 is this one. 0,
So if
1, 2, 3. I'm gonna return this value 2. So I'm gonna return the majority element.
So if the array has, let's say 1 1 2 2 3 3 3.
Okay, let me. Okay, wait. Let me write that.
I still feel it's going to fail some cases as well. I don't know. I feel like that.
Yeah,
okay, let's just write it. What you said? 1 1
1 1 2 2
2 2
3 3 3
3 3 3. Okay, let's see if this validates this rule n minus 2, because they say it's going to be always some element that are greater than n minus divided by 2. So if this n 3 6 7 7 7 splits by 2 3 5, so there should be at least 4 elements here. This is 2, this is 2, this is 3. So this is not a good case to test, right? Because there should be 4 elements here. Let me repeat, maybe you didn't understand. So there is a rule.
I get what you're saying.
Yeah, there is a rule that every array we're gonna test on, it should, one of these elements gonna be greater than n divided by 2, right? In this case, we don't have this rule. This one is not, is less, this one is less, this one is less, right? So if this rule is true, this logic or this algorithm is gonna be always working. So you sort them and you just get the elements in the middle. let's make this one true. We're just gonna add elements, so we can flip this one. Let's make it 3. So this way they are more than this rule is valid. We have an element in this array that is greater than the n divided by 2, right? So if we sort them like here, it's gonna be 1 1 2 3 3 3 3, and I'm gonna look for the index length divided by 2. The length of this is how much? 1 2 3 4 5 6 7. 7 divided by 2 is 3.5, so it's gonna be 3, and 3 is this element right here. 0 1 2 3. Index starts from 0, right? So it's gonna be the element 3. Is that the majority element? Yes. Okay, someone said not sure max work that way on dictionary like object. Since you are using counter objects, you can call the most common method with one first argument. Maybe you're right. I guess you're talking about this one, right? Max hash. I'm not sure actually if it's gonna return the key. Maybe hash value. Maybe not sure. So, but we can test it, right? Okay, so let's create a hash.
Let's test it.
Dictionary. Dictionary hash, and then we're gonna do like a key 1 that have 4, for example, key 2 that have 5, for example, and then print max hash. It should return 2. Yeah, so it does do the job. So it's compared.
So what you want to do is actually make the value for 2 3, right? So you see that it is sorting by the keys, not the values.
Not the values. Oh, okay.
Right,
So
so
let's
by
do
default-
0.
I think.
Oh, you're right.
Is it?
Oh, you're right.
So, yeah.
So it takes
Then it marks on the keys.
key.
By
So
default, like objects are sorted by their keys.
what can you repeat what you said the last? The keys?
Yeah, so basically what is being passed to your max function are the keys. It's 1 and 0. Right?
Yeah, so it's not gonna work. So we need. I don't know what we need. Okay, let's come back to this one. This solution, who did not understand it?
I think that's the best solution for me.
Hash, key hash. Okay, this also probably not gonna work because it's using hash. Okay, so this is probably the
for
best.
Me, I kind of have a question.
Yes, go ahead, please. Yes, go ahead, please. Why is this muted? Okay, who is someone said I have a question. Please go ahead.
Okay, so can you bring up the sketch that you're doing?
Yes. Can you repeat?
Yeah. Okay, so for the scenario, so for the case, for the n divided by 2 case, so does it apply to like the array? Maybe let's say the array has like an odd number, which is like 7. And then will the case be like wrong, and does it like actually execute, or it doesn't like consider itself in the case of like the case is not there, and then you won't be having any question unless the case be correct, and then that's where you can actually do the process.
Okay, I'm not following. Are you asking about the problem or the solution of that we try here?
Okay, the question itself.
Yes.
Okay, go to the condition of saying n
Oh, this one.
divided by 2, right?
Yes.
Yeah.
Yes.
The majority element is the element that appears more than n divided by 2 times.
Yes.
We assume, okay, the majority element is always in n. So what I'm not understanding is what happens if you have like an array which is like 1, 2, 3, 4, and then 8, 8, or something like that.
Okay.
And then when you
wait,
order,
let me write that, please. What you said? 1.
Okay.
1 what?
2.
2.
1, 2.
1, 2. Like
3.
this. Like this?
No. 1, 2, 3, 4.
3, 4.
Yeah, but 1, 2, 3, 4, 8, 8.
8, 8? What you said?
Yeah,
Oh.
8.
Okay. This array, right?
Okay, say your solution to the question was to make. Or can you try solving it, and then I should be able to understand.
Okay. So you're saying
how you do it.
Okay, so you're saying how we can solve this with this code?
Yeah.
Okay, that will not work because we are trying to solve a specific problem, and one of the rule of this problem is the array should respect this rule. The array we have here doesn't respect that rule, so it will not work.
Okay.
Now, why this array doesn't respect that rule?
Now I understand.
Okay, you get it? Yeah. So because if you don't have this rule, if they didn't say, you might assume that majority of elements always exist in the array, you will need to find another way. I hope it's clear. Anyone have any question? Please go ahead. I'm gonna repeat why this array doesn't respect this rule, because they said that always assume that one of these elements, 1 is element, 2 is element, 3 is element, 4 is element, 8 and 8 are same element. They say one of these elements gonna be always more than the half of the array, so n2. N is how many elements we have. So 1, 2, 3, 4, 5, 6. 6 on 2, it's gonna be 3. So one of these elements in this array gonna be greater than 3. So let's say 4. Do we have any 4? Do we have any element that repeats 4 times? No, we don't. This one repeat 1 time, 1 time, 1 time, 1 time, 2 times. So this logic will not work. Okay, we jump to. Okay, so there was this right here. Let me try test this. Give me a second. Okay, let's try to understand it. Key hash get. I didn't get it.
So the thing is, the max function takes optional key argument, right? So that key argument is a callback function, right? You pass a function that will be applied to every element in the iterable. So it's saying hash.get.
Okay.
Right.
So when you do this, does it sort with the value?
Yeah, it sorts with the values, right? So like I told you, when you use max on a dictionary, the keys are passed to the max function. right? So in this case, every key will be passed to hash.gets, which will return the value, and that will then be passed to math.
Okay, that's really smart. Python is amazing. Okay, so we have two solutions now. We have this solution of sorting and take the middle, and just using a counter which gonna create a hash map for each element and the number frequency that it gets repeated, and we can use this technique to get element. If you are you are new to Python or you didn't learn Python, you don't need to worry about like the code itself or like this technique itself, as long you understand the problem and like the solution. So the solution or pseudocode is like, let's sort the array and take the middle element. So you can do it in C, in JavaScript. It doesn't matter which code, right? Now, one of the thing that I wanna mention is this algorithm. I'm gonna post 1 second. It's kinda made to problems like this, so it will be nice if we're aware of it. It's called Boyer-Moore voting algorithm. So the Boyer-Moore voting algorithm is one of the popular optimal algorithms which use to find the majority element among the given elements that have more than n divided by 2 occurrence. This works perfectly fine for finding the majority element, which take 2 traversal over the given element, which work in ON time complexity and O1 space complexity. Okay, let's try to apply this algorithm for this problem. Let's take this example. Let's start fresh. So the problem starts. Okay, let me write. Okay, let me write like just the core, and then we see how it works. So we're gonna have a count variable. It's gonna be 0. Then candidate, which gonna be none. Then we're gonna loop on the array itself. So for num in nums, and then if count equal 0, we're gonna do candidate equal num. Then we're gonna check if num equal candidate. We're gonna do count +1, else count -1. Then we're gonna return candidate. Okay, let me explain the code, then we see how it works. So because we are sure that we're gonna have n divided by 2 like majority elements, so we don't need like 2 for loop, we can do only 1. So how it works, we're gonna create a count variable that's gonna start with 0, and then we're gonna create the candidate, which is gonna save the element candidate. It's gonna be none at the start, and then we're gonna loop on the element. So at first we're gonna be on 2, right? We're gonna be on 2, and we're gonna check So the loop gonna be looping this phase right here. We're gonna check if the count equals 0. If the count equals 0, we're gonna go to candidate variable and put the number. So at first, of course, it's gonna be 0, so we're gonna put 2 inside candidate. Okay, so 2, and then the second block is we're gonna check if number is equal to candidate, and because 2 is equal to candidate, it's gonna be true, so we're gonna do count plus 1, so this gonna be 1, and then we're gonna loop again. We're gonna go to the second number. Again, second number, we're gonna check if count equals 0. It doesn't equal 0, it's 1, so we're gonna jump to if. If number is equal candidates plus 1, so number is 2, candidate is 2, we're gonna do another plus 1, so it's gonna become 2 here. We're gonna loop again. This time we have a new element. We're gonna see if count equals 0. No, it's a 2, so we're gonna come here and see if num equal candidate. It's not equal, so we're gonna enter else. Else we're gonna do count minus 1. So this one is 2 minus 1, it's gonna become 1. Then we're gonna loop again. We're gonna loop again. This gonna move here. Count is not 0. Number equal candidate, yes. 1. Oh, sorry, not equal candidate. Candidate is still 2. So sorry. So where was it? Yeah. So 1. It's not equal candidate, so we're gonna do minus 1. So this gonna become 0. Then we're gonna loop again. Count equals 0. So we did loop, this gonna be 1. Count equals 0, so candidate is gonna be equal num. So this value of candidate is gonna change. So it's gonna become 1. And then we're gonna check if number equal candidates. Number, this one equal candidates, yes, they are equal, so we're gonna do my plus 1 here. So 1. We're gonna loop again, and this time then we're gonna check if count equals 0, it not. If number equal candidates, it not. Candidate is 1, number is 2, so we're gonna do minus 1. Minus 1 here, it's gonna become 0, and then we're gonna loop again. We loop and we see if count equals 0, yes, it's equal 0, we're gonna put candidates equal num. So 1 gonna become 2. I think someone forget to mute the mic. Okay, so we put 2 here because count is equal to 0. And then we're gonna see if num equal candidate, yes, then it's gonna be 1 here. Then the loop gonna finish because there's no more numbers, and we're gonna return candidate, which is 2. So this is the algorithm of like Boyer-Moore, how it works. It works like this. You keep going using 2 variable, so the space complexity gonna be 0, 1. It's gonna be always the same, even you
That's
loop it.
interesting.
Yeah, if you wanna keep the space complexity to 0, 1, I think they mention it here. Could you solve the problem in linear time and in 0, 1
That's very interesting.
space? You will
Wow.
have to do it with with this algorithm.
Wow, I never thought about this.
Me too. I just learned it from here,
Even
which
if
is good.
those
Because at the end of the day, if you look at the whole thing, the non-candidates are actually half the array, and why the real candidates are actually half the array. So that's the way he did it. So some parts are increasing, some parts are reducing. At the end of the day, the real candidate is when it's 0. So that balances the array completely. That's interesting. I
Yeah,
get
it's
it.
really cool. It's
so
really
it
cool.
works with
But I still think sorting and split in the middle is nice. Yes, please go ahead.
it works with both sorted and unsorted arrays.
This method, yeah, it doesn't matter if it's sorted or not.
Someone's mic which is a bit noisy.
Oh. Okay, you have any question? Wait, so I think Mahmoud, you have echo. Can you repeat?
Yeah, I was asking whether it works for both sorted and unsorted arrays.
Yes, it works for both. Okay, let's code this one, or let's code which one you wanna code, guys. We can code this one.
Sorry, I have a question, please.
Yes, please go ahead.
If we code the first one, the sorting, and this one, is there a way we can check which one is faster
Yeah.
in terms of time complexity?
Yeah, let's check them both. So the sort. Why you angry at me? Okay, so the sorted way, I think this one. Return. So we're gonna sort them, and then we're gonna do the length, and then we're gonna split the length on two. Okay, submit. Okay, so I guess we can take screenshot of this. Sorted. And we can check also this one. The one that in gases. This one. And then we can compare them and see which one is more. Okay, run.
Change the capital H to lowercase h.
Ooh, this one is faster.
Come on.
Very fast.
Hash count.
Yeah, Gasti.
Okay, so this one is okay. Let's see the algorithm Boyer more. So we have count,
Nah, Boyer will win. It's just O of n. That one
but
is
only
perfect.
space. Maybe time complexity gonna be.
Yeah, even the
different.
time complexity. It just goes through once.
Yeah, exactly. Boya will be better.
Although, to be fair, if you're doing the max, you're only doing the max of 2 things. So what's the time complexity on 2 items?
Candidate equal num, then if num equal candidate count plus 1, else can't. Oh, we can't hear you, Mutasm, if you are talking. You have like a noise background. Yeah, we can't hear you. Oh, there's no much difference here. Wait, where is this noise coming from? That's not so much difference, I guess.
So the first solution had the best memory or
Yeah.
space complexity.
Yeah, I think the hash was like the best time complexity. Okay, who have question? By the way, if you say your mic is muted, you probably have background noise. Just send a message in chat when you mute your mic and I remove it. I really still don't get the solution just for the for loop. Okay, so this solution, Tosin, this one. Is it this simulation how code work, or how, like, do you have any like specific questions? Not the for loop. Which one? The hash map? Sabah. Okay, Sabah solution. So let's go back to it. And if Sabah wanna explain it, yes, go ahead. So this one, right? How do we do it? Okay, so we have, yes, Sabah, go ahead.
I want to explain it. So basically, any number that you have that is like reoccurring in your array, more than half of the array, if you put all of them together, basically sorting them, it's gonna, like, one of them is gonna be at the middle, since the reoccurrence of it is more than half of the array. So basically think of it as like water in a bottle that is more than half. If you look exactly at half, you're gonna find water. I hope that explains it, guys.
Yeah, I think this was clear. Did you get it, Torsen? Okay. Okay, so let's jump. If this is clear, let's jump to second LeetCode, which is add binary. But let's make sure that everyone understand this one. If anyone have any question, go ahead. Okay, let's jump to the second problem. Let me post the link. We did kinda something similar to this before, I think in bitwise PLD, but let's do it again. This time we have string. So given two binary string A and B, return their sum as binary string. Example, input A 11 and B 1. Output is 100. Example 2 is A 10 10. I don't know the integer variable or like number, but basically we're gonna do like addition between two,
that's binary addition.
Yeah, between two binary number, and we should get the correct result. A and B consist only of 0 or 1 character. Each string does not contain leading 0 except for the 0 itself. So how are we gonna solve this? let's take it to the lab and see. Okay, move this here. So if you were here in the bitwise PLD, we saw like XOR, and we saw how we can save the carry. So let's start with the basic, because someone maybe didn't see that. So if we are gonna take this example for example, so we have 1 0 1 0, and then we're gonna do addition with 1 0 1 1. Now binary addition, how it works, it's gonna be like this: 0 and 1, it's gonna be 1, 1 and 1, it's gonna be 0, but we're gonna do a carry here. So whenever we have 1 and 1, we're gonna always put 0 and put 1 on the next numbers. Now 0 and 0 is 0, but because we have carry, it's gonna become 1. It's like 0 plus 1, so it's gonna become 1. And 1 and 1, it's gonna be 0, but we're gonna put carry in next number. Now the next number is 0 0, so 0 and 0 is 0 plus 1 is 1, which is like exactly the output here, right? 1 0 1 0 1. So this is the addition in binary, how it works. And to do something like to solve this problem, we're gonna use bitwise, right? Yeah, go ahead. What you said?
Could you repeat? Because I was out for a moment.
Yeah, it's okay. So, so to understand the problem, is like we're gonna do addition, add binary. We're gonna add this binary number to this binary number. We're gonna add them together. So before we do that, we need to understand how the binary work, addition in binary work, right? Now, let's say this number with this number. We're gonna do addition. Let's do binary converts. Let's say, what is this number? 1 10 10. How much is that? 10 10 binary to decimal. So it is number 10. So this 10 10 right here is 10 with the binary integer, right? 10 integer is represents binary like 1 0 1 0 1. Now this one is gonna be 11 in integer or decimal. It's gonna be 10 11. Now if we did 10 plus 11, it should be 21, right? So
Yes, sir.
so if we did like the addition of this, we need to find out the same number of 21 representation in binary. Now how the binary work is like 0 plus 1 is gonna be 1, right? But the only difference is when you have 1 plus 1. When you have 1 plus 1, you don't write 1. You write 0 and you put a carry here. So you put 0 and you add 1 to the next number, or like it's like a carry. So 1 plus 1 0, and you put carry. Now you deal with this number, and after you finish the result, you then gonna add carry to it. So 0 plus 0 is 0, right? But we have a carry, so we need to add this carry to this 0. So 1, because 0 plus 1 is 1. Now we go to the next element. 1 plus 1, we said 1 plus 1 is 0, so this is gonna be 0. and we add a carry here for next number, right? Now the next number, there is nothing written here, but we assume there is 0, right? For example, 8-bit or like 16-bit, so there is zeros on the left, right? So 0 0 0 plus 0 gonna be 0, but we have carry, so it's gonna be 1. So this number should be representing 21. Let's see if that's true. So 1 0 1 0 1 1 0 1 0 converts 21. So I guess it's clear now, right? Let's see bitwise operation just quickly, just to like remember the XOR. So for example, so one of the operator in bitwise, we have AND, we have OR, we have XOR. Now AND, let's take this here, and okay, now we want to use one of this to do this operation right here. Now the problem is we don't have some operator that do this directly, so we need to combine them. Now we know XOR give us similar thing. If we have 0 0, if we have 0 0, it give us 0, 0 1, it give us 1, 1 0 give us 1, 1 1 give us 0, which is something we want, right? Because when we have 1 1 1, we need 0 here. When we have 0 1, we need 1 here. And when we have 0 0, we want a 0 here. 1 1, we want to give us 0. And then we're gonna see how we can generate this carry. Okay, so the formula to generate carry is this. Let's say this is X, this is Y, and this is let's say this is the result X and Y, and this is the result. Now the results after using XOR is this, but the true result that we want is this. This is 21. Now when we're gonna use XOR, it's gonna give us 1 1 1 0 0 0 0 1 1 0. Now we just need this carry to add it to this, right? For example, how the carry gonna be? It's gonna be 1 here. Yeah, we add carry here, so 1 here and 1 here. So this is our carry, right? And then 0 0 0, and then we do plus this result with carry. Now let's see what this gonna give us. 1. Of course we're gonna use XOR again, right? XOR. So this is XOR. XOR is like 1 0. It's gonna give us 1. So XOR work like this. If they are different, it's gonna give 1. If they are the same, it's gonna give 0. So 1 and 0 are different, so the result's gonna be 1. If 1 and 1 are the same, so it's gonna be 0. 0 and 0 are the same, so it's gonna be 0. So whenever it's different, 1, if they are the same, it's gonna give us 0. So this is how I remember XOR. So in this case, 1 and 0 are different, so result is 1. 0 and 0 are the same, so it's gonna be 0. 0 and 1 are different, so it's gonna be 1. 0 and 0 are the same, so it's gonna be 0. Now 0 and 1 are different, it's gonna be 1. Now notice this is the same result we're looking for. 10, 10, 1.
So, sorry, could you repeat the carry part? How?
Yes.
How are we moving the elements we carried to the carry so that we do the addition?
Okay, so that's what I was gonna go to next phase, is like how we can generate this.
Okay.
How we can generate the carry, because if we generate this number, then we can just do XOR again and find the result, right? So
Yes.
the carry is, we're gonna generate it from X and Y. So it's gonna be X and Y, and we're gonna shift it by 1. Let's see how this formula gonna work. Now let's remove this carry. Let's generate carry with this formula and see if it's gonna give us the same. So we say X and Y. So X and Y, so 0 and 1, and 0 and 1 is gonna be 0, right? Because 0 is like multiplication, or like in normal math. So 0 and 1 is gonna be 0. 1 and 1 gonna be 1. 0 and 0 gonna be 0. And 1 and 1 gonna be 1. Now this is kinda the same carry that we want, just we want it to move a bit to the left. If this move right here, it's gonna be perfect, right? Because notice we need one here, so here is it, right? So that's where the shift come from the left by 1. It's like you say, after you do the end, you're gonna move this 4 number by 1 to the left, so like this. And then notice, now we have the carry that we're looking for, it's here. We have this carry we're looking for, it here.
Yeah, makes sense.
So after that, we just gonna apply the XOR. Now when we're gonna apply the XOR, this gonna be our result, right? And if our results, we need to check if our results still have carry, because carry need to be 0. Because as long as we have something in carry, like we have something in carry, we need to do XOR again. So this gonna be like a loop. So results, and then let's see the carry, right? Let's see the value of carry. We're gonna apply the same formula. Now our X and Y gonna be this. This is our X and Y, and this is the result. So if we apply the carry on this, it's gonna be 1 and 0, 0, 0 and 0, 0, 0 and 1, 0, 0 and 0, 0, 0 and 1, 0. So our carry is 0. That means this is the last result. Then we know this is the correct value. But if some point, let's say this was 1, right? Okay, so if this 1, we keep doing the same thing we did before. So it's gonna be a loop.
So you have to keep track of the X, Y, the result every time you're looping, and checking it with the carry every time and comparing it and stuff. That makes sense. Thank you.
Okay, let's see. Let's write. Let's transfer this to a code. Yes, go ahead.
I don't know how you got the 0000 for the carry.
This one, or this one? The last one.
Last one, yes, that one.
Okay.
Yes.
So let me try. Okay, so our new X and Y is this, right? Did you understand this part? I can repeat.
Yes, I understood that part.
Okay, so this X and Y, it gives us this result, right? Now this result, we don't know if it have carry or not. In other way, we don't know if we have some numbers here, we are not aware of them. So we apply the same formula that we did here, right? This one. We're gonna apply the same formula on this and see if it's gonna give us some of them 1. So if we apply the same formula, it's gonna be x and y. So 1 and 0, it's gonna be 0, right? 1 and 0,
Yes.
0. 0 and 0, 0. 0 and 1, 0. 0 and 0, 0. 0 and 1 is also 0. Because and it's gonna give 1 only if both elements 1. So and it's gonna give 1 only if both elements are 1. As long they are not 1, both of them, it's gonna be always the result 0. And notice that when we have carry, which case here we have carry? When we have both elements 1. Right?
Yes.
So whenever we have carry, this we're gonna find someone somewhere here, because 1 and 1, it's gonna give us 1. So who have any question? Wallace. Yes.
Yes, I'm kind of lost because we ended up talking about the addition, right, of the
Yes.
binary, and then somehow we ended up using the ZAR and the AND and the other conversion systems, which I don't even understand.
Okay. So you said you don't understand. Do you mean the AND how it work and the shift how it work? Which part do you don't understand?
So
like this condition.
Can you bring up the table that you did?
The table.
The table with
this one?
Yes, exactly. So I kind of understood, like, I kind of understood it, but as soon as you were like kind of explaining it, or like using the examples and stuff, I couldn't understand what was going on.
Okay. Do you know specifically where where did you lose last track? Like, is this part? Did you understand this part?
Yeah, the addition part. Yeah, I understood.
Okay. What about the carry? Did you understand?
Yeah, that one, the carry.
Okay, this one you didn't understand.
What was the carry? Yeah.
Okay, so let's see this. Where is it? Okay, let's do it here. So let's remove this carry from here, and let's say, okay, wait, let's just write it in the other 10. Okay, let's do it here. So we have this number 10, 10, 10, and we have 10, 11. Now to do like addition in binary, we're gonna so like this is how the normal addition gonna look. It's gonna look like this: 0 plus 1, 1, 1 plus 1, 0.
Yeah, I understood that.
Okay, yeah, I'm gonna try to go from here to carry because they are related. So now when we do 1 plus 1, we have 0, we have this carry right here. Now this part right here, do you understand where it's come from?
I'm understanding it.
Yeah, so now then we're gonna go here, we're gonna do 0 plus 0, it's gonna be 1 because we have 0 plus the carry 1, and then 1 plus 1, it's gonna be 0, and we add the carry, it's become 0, 0, 0 plus the carry is 1, right? So far it's clear, you understand this part?
Yeah, I understood it.
Okay, now there is no way to do this using bitwise directly. There's nothing that can allow us to do this. There's no like plus we can just do this. So we have a problem here. How we can do this result with combination of bitwise operator? So it's like we're gonna combine multiple operator together to reach this result right here. So far clear?
Yeah, okay.
So now
I'm getting it.
we found idea is like XOR. This XOR right here give us half of the solution. Now if we apply XOR on this X and Y, we're gonna get half of the solution. Now XOR gonna give us 0 if they are different. If they are different, it's gonna give us 0. Sorry, 0 if they are I forgot. Yeah, difference gonna give us 1 and 0 if they are the same. Now this is the operator XOR, right? Is this clear? Is it clear how the XOR work? Wallace? Hello, Wallace? Hello, hello. Can you hear me?
Yeah, yes.
Is the XOR clear? How XOR
Yes,
works?
it's clear.
Okay. Now let's use XOR on this one and see what is missing. Okay,
Yeah,
so if
it's
we use
clear.
XOR on this, 0 and 1, we said if it's different.
Yeah, I can hear you. I said it's clear.
Okay, there's delay.
Yo, I can hear you.
Yeah, there
I
is
said it.
there delay.
I said it clear.
Try to reboot your internet.
Oh, okay. Cool.
Try just disconnect maybe and enter, and we continue.
Okay.
Okay, let me know when you come back. Okay, let's wait like a minute or so. Wallace, you here? Can you hear me? You can hear me, Wallace?
Yeah, I'm back now.
Okay, I'm gonna count from 1 to 3 and then you start counting from 1 to 3. Is that clear?
Okay.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9,
Stop.
10. Wait, you didn't start counting.
Oh, you said what?
So
Oh,
I'm
repeat the question
gonna
again.
count from 1 to 3 and then you start count after me. 2, 3. Is that clear? Hello?
Mm-hmm.
Okay, I think there's still delay. Hello, Wallace?
I'll start counting at 3.
Okay, yeah, okay, I start. 1, 2, 3, 4,
Yeah, I can still hear
5,
you.
6, 7, 8. Okay, there's still a huge delay. Okay, I will continue and then you can watch the recording and then if you have questions, just send me DM.
Oh, okay, cool.
Okay, so let's continue. So we said XOR, if we apply it on this, it's gonna give us half solution. Now this is the solution we are looking for, right? So XOR, it's gonna be different. It's gonna give us 1. If it is the same, it's gonna give us 0. Now 0 and 1 are different, so it's gonna give us 1. 1 and 1 are the same, it's gonna give us 0. 0 and 0 are the same, it's gonna give us 0. 1 and 1 are the same, it's gonna give us 0. 0 and 0 are the same, it's gonna give us 0. Now, this part, what's XOR gonna give us? So we still need like to add carry. we still need something here missing. So this is the XOR. And the carry 1 and 1. We need to add this carry to this XOR, like plus here, like another XOR with carry, so we can reach to this result, right? Now the carry, how it works is like this carry right here is 0 0 1 0 1, right? 0 0 1 0 1. Let's apply it here. 0 0 1 0 1. Now this is the carry that we need to add it to the result that we get from XOR, so it can give us this. So 1 and 0. So we're gonna apply XOR on the carry with the result. 1 and 0 are different, so the result is 1. 0 and 0 are the same, so 0. 0 and 1 different, so 1. 0 and 0 are same as 0. 0 and 1 different, so it's 1. Now notice this is the same result as this. Now this carry, we can get it with this formula, which is x and y shift by 1 from the left, from the right, sorry, or like shift it to the left. Let's make sure this actually give us this, because if this formula give us this number, then boom, we finish, we find the solution. Now let's try it, x and y. So in this case, x is 0 1, it's gonna be and 0 and 1, it's gonna be what, 0. 1 and 1 gonna be 1, 0 and 0 gonna be 0, 1 and 1 gonna be 1, 0 and 0 gonna be 0. Now we're gonna shift it by 1. So we're gonna select it and shift it from the right by 1. And then we're gonna put 0 here because we shifted. So when you shift, you add 0 from the right. If you did right or if you did left. So we did use right, so this gonna add 0 from the right side. So notice with me, this part is exactly this one. Sorry, this one. Where's this one? Yeah. So 0 0 0 0 1 0 1 1 0 1. So we have the same carry. Now how we can code this? So to code it, we already did this. So we're gonna create like a while loop. Okay, let's write the results.
How do we handle two strings not being of the same length?
Two string are not same length. That's a good point, because this one are string. This is a string, not number, so we need to convert them. So for example, if they give us to convert them, we can use the int, right? So like print int, and let's say they give us 10 10. It's gonna give us 10. So we need to convert them, because bitwise operation and XOR and shifts to the left or the right, it doesn't work on like strings, it work on integer. So we need to get this value string, like this is 11, this is binary, not integer, right? So we need to do something like this, 10 string, and 2 it means like it's a binary representation.
It's the base of the number. Okay.
Yeah, and it's gonna give us like 3. I think hexadecimal is like 10. 10 or something.
Hex, I think it's either 8 to 16. Forgive my
16.
poor mathematics. I don't know.
Yeah, 16. So A in hexadecimal is representation of 10 integer, and B is 11, I believe. 11. So now we're just gonna use if like you new to Python, like don't care that much about this part. You can do it in C, you can do it in JavaScript. It just you need to find a way how to convert a string representation of binary to a real integer. In this case we have like this number 11, and we're gonna convert it to integer. We're gonna use this int. It's gonna give us like 3, and then this number what we're gonna like work on it with the bitwise.
I have a question.
Yes, please.
Is that being true to the question? If we use that method to transform it from the string to a number format, should we not be using the string to, you know what I mean, perform the operations? I'm just asking.
Yeah, but we're not gonna do like a plus b, right, like this, because at
No,
the
for
end,
sure.
yeah, because at the end we need to convert it again to a string from the integer, and then send it.
Okay, no, I was just asking if we're not cheating a little bit.
But like there is no way to do bitwise without convert it to integer. Like if I want to use or XOR or shift left.
No, for sure. But my question is, and just hear me out. Is it
like
not cheating by transforming it? Okay.
I don't think so. Who think it's cheating? Okay, let's see. Maybe it's cheating. Let's see. Given two binary string and be returned their sum as binary.
I have a suggestion.
I don't think so.
Because essentially we could transform it to an integer, then do the mathematics in the integer format, and then, you know what I mean, swap it back into string format.
I think that is cheating.
Okay.
If we did like a plus b, I think it's cheating.
Okay, understood.
But like if we use bitwise operation, I think it's I'm not sure. Maybe there is other solution.
Okay, Harp has a question or a suggestion.
Yeah, please go ahead.
So my suggestion is, since it's a string we're using, we're only using ones and zeros, so we can just go through the string and get those values individually, then run the operation on them. Since we know that at a particular point in the string is either 1 or 0, so if we check the string and we find that character is, then that means we have to start from the back. Yes, we have to start from the back or from reverse. Then you check the character. If it's 0, you check the characters of both strings. If it's 0, 1, you do the operation on that one. Then you do on the next string like that. Then we'll be able to get maybe an array that has all the carries, and then an array that has all the that's the XOR values. Then we do the same operation on it again if we need to do carry. So I'm just thinking maybe something like that.
So like this gonna be a pure string manipulation?
Yes, like string manipulation, but we already know the value. So it's like if you see the character 0, represent it as 0.
Okay, do you have like a pseudocode for that, or like a code for that?
No, I'm just
Sabah.
thinking out loud.
Was
Sabah
my
Can you
Sabah.
write something down?
assumption as well.
Yes. Can you repeat? What you said, Ningasi? Sabah said the return their sum as binary string does not enforce the use of bitwise. Yeah, that's true. I guess you can solve this in many ways, but like my point was like using bitwise operation is not cheating.
Yes, I also have a question. What if the length of the string is like 1,000 character or 1,000 bits? Because from what I saw in the constraint is like the length of each string should be between 1 and 10 to the power 4. Are you still gonna convert that into integers using the formula you were talking about?
Wait, I think Ningasi is lagging. Hello, Ningasi. Someone said something about converting the string.
Yes, I was talking about that, about the length. Like, since you are trying to convert the string
Yes.
to integer, what if the length of the string is like for 1,000 character? Are you still gonna convert that into integer?
Yes, I think it's still able to convert, right? If you like, you did, for example, this, it will still convert it.
I mean, I'm talking about the length.
Like this one.
Like
even
yes,
if you put
1,000 character.
It will still convert it, right?
Okay, it will still work. It will not overflow.
In Python, I don't think it will overflow. In other language, it may overflow. So 10 4. So the length. I don't think in Python can overflow. Okay, so so I see some solution here. This one. So this one can be cheating. It sounds like cheating, but it's legal, right? Because it works. Okay, see this one. Add binary, carry. So this one is like changing the string, manipulating the string. Okay, so is it this same solution you were talking about? I think harp or someone. Okay, let's code one of the solution. Let's try to code this one first. This one that we did. I still think this is the most efficient way, the bitwise. But I think all of them can work. How we can do this one? So we're gonna have like x and y and answer. So answer is gonna be like the XOR, right? So this is the result. Let's say result. Results gonna be coming from XOR. So x XOR which is the source, think like this. And then after the XOR we need the carry. So carry, it's gonna be we said X and Y shifted by 1. What else? When we shift it, now this is gonna be in loop because we need to be looping, right? While carry, so we're gonna loop as long carry have something. As long carry
I think it should come after.
I think so. Wait, Pascal, what did you say?
No, it's okay. It's okay. Yeah, it's correct. Go ahead. But I'm looking at the while loop. Like, okay, what about the carry? I mean, at least at the initial stage, it has to be null, right? Because how can it come inside there when you've not calculated anything yet?
Yeah. So carry at the start is gonna be carry gonna be what, 0?
It can be. That's what I'm saying.
Let's say 0. I mean, maybe 1. I think we can. Okay, so we need to save the result. Okay, we can do a temporary variable, or we can.
I was thinking you would do the calculation, then later on do the while loop after the calculation. That's what I was thinking.
You're not updating X and Y. Okay, so we can do tuple X and Y equal the result and the carry, and then here we do Y, which is gonna be carry, and we can put X, Y equal the ends of this.
That's the the binary numbers. Yes, exactly.
And B. A, but I need to convert them, so it's gonna be int A2, and Y is gonna be int B2. Okay. So we convert the A and B, we put them in X and Y, like here. And then while, because this carry gonna be changing every time we do this result, is like we're gonna put this in Y, and then while Y.
Sorry, what? If you're adding Y, if Y was 0, are you aware that this might not work? I mean, the loop won't work.
But I think, wait, did they say something here about it?
Okay, I think they said, yeah, it's not going to start with 0. Yeah, you're correct. Go ahead.
Okay, so let's see if it's gonna work. Okay, I saw something here. So this one, to convert it back to, because we need to return string, right? So return okay, if someone didn't understand the code, maybe because Python or something, it's okay. Like as long if you did understand this as like concept and pseudocode, you can try find a way to convert it to language you are using. It's okay if you didn't understand this, if you don't understand Python. Or if you have a question about anything here, you can ask and we'll try to explain. So now we're gonna do this to like keep looping as long as the carry become 0. One of the PLD we did bitwise operation, it have like we did explain this in details. You can come back to it. This one, binary. So we did explain this. I think it's almost same problem in details, where it will help you understand it. Okay, so we continue with return. What we're gonna return? We're gonna return the result. The result is where it's gonna be the value, but if we did return results here is an integer. We need to convert it from integer to string. We're gonna use this right here, bin. Now let's say we did bin.
Sorry, can't the str work? Str, is that possible?
Let's try it. So let's say we have variable or like number equal 5, or let's say 3. Now if I want to return the binary of it, so it is integer, right? So I need to return like the binary of it. So I'm gonna do bin num. It's gonna return 0b11. So this is like this is in binary is 11, right? And this 0b is like it's saying the next number is binary. So we need to cut it out. We need to cut this. If you notice here, they just return 100. They don't return 0b100, right? So we need to cut it out. That's why we're gonna do like
that's correct.
We're gonna do 2 to cut it in Python. You do like cut the first character and then dot to keep the last element 11. So we're gonna use the same result, pin result. Let's see if it works. Before we see how it works, who have like some question for this? Let's do.
Okay, my final question for this is,
yes.
So this slicing makes it a string automatically, right?
The bin is gonna convert it to.
Okay.
So.
Okay.
So let's say bin number. Type. Is it type of? Type of like this? How to see type of this?
You use type. Use type. In brackets.
Type, okay. Then pass it as an argument.
This string. So this bin is gonna return a string.
Oh, okay. Thank you. Nice.
So we just need to cut this part.
Thank you, boss.
You're welcome, boss. So just like go through the code one more time. So we said X and Y. We're gonna do.
I also have a concern, please.
Yes, please go ahead.
What if Y or B is equal to 0? Then they will not enter your while loop.
But is that something possible there?
only consists of 0 or 1 character.
I'm not sure.
So, I mean, like B can be equal to the 0 character itself. Yeah, and then in that case, when you convert B to integers, then it will give you Y equal to 0. And then your while loop will not enter anymore. And I mean, I think you need to check it first before.
Maybe it's edge case.
Yeah.
But here they didn't say
Based on
any.
edge case, exactly.
Here they didn't say that the number can't be 0, right? Only of
But they didn't also.
So
they didn't
I
also
think-
say it can't be 0.
Yeah, so if the case was 0, it's not gonna work.
Yes.
I think it will not.
That was what I said earlier. But I thought there was a case. The question was saying that they
Yeah.
will start with a 0.
Yeah,
So
but we can.
if they actually have a case where where Y is 0, you have a problem really. It won't work.
Yeah, but let's try it. Let's try it and then create a test case of 0.
Yeah,
and
let's
then
try it.
we
Yeah,
see a
exactly.
solution. I just want us like split, like show this code, like which each part, where is it in the code. So this result right here of the X and Y, it is this part right here. So this is the XOR. And we said that we're gonna, after we calculate the results, we're gonna see the carry, right? And this is the carry part. So it's same formula, right? And then
Sorry, can I make a suggestion? Okay,
Yes.
go ahead, sorry.
and then
Okay.
yes, go ahead.
Sorry, please.
You go ahead.
Just in case it fails, just because of the 0 thing, I was just thinking you just use infinite loop. Then when the carry is 0, you just break from the loop there. That's what I was thinking.
That's a good idea. You can do that. That's smart. Okay, let's try it. Let's try it. Okay, I already called it. Okay, let's run it. And then we'll create a test case, see if out 0, okay, it work, or submit. So the 0 didn't work. So this is the error in the logic. Now we can try the way Pascal said. Is like this kind of while true, and when the carry, if carry is equal 0, we break. I think. Oh, it worked. Okay, that's nice. But this is just one of the solution. There is many solution. There is this one, manipulating string. There is this one, which is actually legal, very legal. You just gonna put A plus B.
Sorry, I have a question.
Yes, please go ahead.
So to be precise, because I have to leave here some minutes ago, so I just want to get some things right. You said x, y equals to int into bracket a2. Are you giving us a tuple or what? Are we having a tuple as that, and what's the a?
Yeah.
I just want to understand that.
This part.
Yeah, oh no, the line after the function as x.
This
x,
part.
comma y equals to yes. Can you just explain more better to get that, because
Which line?
yeah, that line. You said x, y.
This one?
Yes. Yeah, that's first line.
Line 3?
Yes, line 3.
Yeah, this is a tuple. I can do like this. So that is same as like this.
Okay. That's what I want to get.
Yeah, it is also same here. Okay, who have any question about this one? Welcome back, Nyingasi. Wallace just gets hit by the tower thing too. Oh.
Hello.
Hey, hello, welcome. Please go ahead.
I have a question
Yes.
about the different codes. So, right, some of them are very short, some of them are very long. I was wondering, like, when we are busy in the interview, which route is the best route to go? Should we go for something that is short and sweet, or should we do the one that will like display our understanding of the logic of the code and do something longer? And if we like in an actual working environment, which way should we go then? Like, is it best to do it the shortest, simplest way that we can, or must we do it in a way that really spells out the logic?
Who have answer for this question, guys? My opinion, I think, don't do something that will be over smart. You know, like something like this. Like this. I think this can be tricky, right? Because think about it. They ask you this question, they know that you can do this, but it will be nice if you present some skill like this, string manipulation or bitwise, like some solution that represents some technique or algorithm or something.
Okay, I understand that. So then, like, if I'm also in a work environment and I'm working and nobody's necessarily looking at my work, what should I do in that case? Does it make a difference, or should I still be?
Probably this one, short. If it was like maybe the time complexity or the space, because I don't know actually how this work behind the scene. So I think it depends. It depends the problem you're trying to solve. If like you wanna have a optimize code, so you probably should check which solution give you the less time complexity, or like if you are caring about space, the less space complexity.
Thank you very much.
If they want smart solution, they must ask smart question. I actually don't know. This is just my opinion. I'm not sure. Maybe someone here can.
I just feel the major thing is follow the requirements. Like every problem has a requirement, just like what the way ALS gives us. So just follow the requirements and you'll be fine. So don't go against the requirement and find a shortcut to the solution. If they find out, then they might mark you down or something. So just follow the requirement. This talking about binary. So using plus here, I mean, it's not binary then. Something else.
Yeah, but it can be fun to ask the interviewer, can I just convert it to integer and do plus? But like even saying it out loud right now, you can feel something is not right? Do you feel that? Like when you see this, you feel something is not right? If you feel that is not right, he probably feels the same. So that feeling exists for a reason.
I would feel like they think I don't know, I'm taking the easy route out. So
yeah,
I don't want them
but
to
he may be
think that
happy, right? And this, what's indigestion mean? By the way, I'm not attacking your solution, Sabah. Please don't be angry at me. It's smart solution.
Yeah,
I like how it looks, because when I look at it, it's so easy to understand.
You must do it hard way, I guess. Okay. Let's jump to the last LeetCode, and it is about binary tree. Binary tree. Okay, let me close this. So let's see what this problem is about. Given the root of binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of paths between two nodes is represented by the number of edges between them. So we are gonna return the longest path. Given the root of binary tree, return the length of diameter of the tree. The diameter of binary tree is the length of the longest path. So we're gonna return the length of the longest path between any two nodes. In a tree, this path may or may not pass through the root. Okay, so this path can be like it's not necessary can be always coming from the root. Maybe it's coming from 5. So 5 maybe have like 5 paths or like 5 edge. So this can be the longest path. Even this one is short. So for example here 1 2 3 4 5 1 2 3 4 5 3 is the length of the path 4 2 1 3 4 2 1 3 or 5 2 1 3 5 2 1 3. So it is like, let's copy it, copy this. So it is like left and right. So 5. So in this case, 3 is the length of the longest path, which is 4 2 1 3. So it's you go from left and right, or from 5 2 1 3. So this edge 1, this edge 2, this edge 3. 1 2 3. This is something we can solve with DFS, right? It's like a recursion function that calculate the height for each node. What do you think, guys? How we can solve it? Or who does have any question about this problem or didn't understand? Who did not understand this one? Or you have some solution to suggest? So if you wanna do it with DFS, so how we can do that? We're gonna launch DFS on the root. It's gonna launch one on the left and on the right, and this left and this like left one gonna launch one on the left on the right, and this gonna launch one on the left on the right, and this gonna launch one on the left on the right, one on the right, one on the left. This is our base case. So the base case is when the node is none, because there's no node here. There's no node, no node, no node. So this can return 0, 0. So 5 gonna do the max between 0 and 0 and add 1. It's gonna return 1. This also gonna return 1. And then this gonna do the max between both left and right and add 1. And it's gonna return 2. And then also gonna return 1. And now we know that roots have on the right one path or one edge, on the left one edge, so we can just do addition between 2 and 1, which is 3, and we save it in some variable, and then we launch another I guess each time we launch defs, we check the return that's coming from h1, so 1 and 1, right? So it is 2, and we're gonna check here if 2 bigger than 3. If it is, then we're gonna put 2 here. It's like we're gonna have some variable that keep track for each DFS. So DFS that's come from here, it's gonna do 0 plus 0 and check this variable. Is it greater? If it is greater, we're gonna put that variable there, and automatically it's gonna keep growing until we find the bigger one. And maybe one of these nodes, let's say this one, is actually the biggest one, right? So maybe this stop here, but this one is really great, or like bigger. Let's say this is going like for 9 nodes. So the height of this, it's like what, 3 and 2. So 1, 2, 3. So 2 and 3. But this node right here actually have 9. So each time we launch DFS and we get value from left and right, we can check it and save it in this variable. If it is bigger, then we're gonna return. So this is one of solution. What do you think? Did I explain it well? Maybe I did go fast. Maybe I repeat. Who are not understanding, I can repeat.
You have to start from the question because I'm still getting it confused.
Okay, so you didn't still get the question, right?
Yes.
Okay, so given the root of a binary tree, return the length of diameter of the tree. Now the question is, what is diameter of tree? So diameter of binary tree is the length of the longest path between any two nodes in a tree. This path might or might not pass through the root. So this path, the longest path, is not necessarily including the root itself. The length of a path between two nodes is represented by number of edges between them. So for example, if we did take this to here, for example, if I want to return the longest, what's it called? If I want to return diameter of this tree, I'm gonna look for the longest path. So 1, 2, 3. So the longest path is between two nodes, 4 and 3. It have 3. The edge, right? 3. Is it clear so far? And between 5 and 3, so 5, 1, 3. It's also 3. So the diameter of, or like the length of diameter of this tree is 3. Now this one is passing by the root, but it's not necessarily, because at some tree, if they give us like a different tree that's, for example, have this node like this, and this one, let's say this one is like a really crazy node, right? Let's just assume there is like 10 node here on the left and 10 node on the right. from this node number 6. Now if we go from 10 node to 10 node, it's gonna be 20, or like the paths, it's gonna be 20. So the longest diameter of this is it longer? The length of diameter of this diameter of branch tree is the length of the longest path. So diameter is the length of longest path. Let me copy this so I can keep it close. Now if we go from that route, from this rule, the longest path is this one, right? Because this one is just 3. This one is what? 1, 2, 3, 4. You see, this one are just 3, 4. They are short. But when we go to node 6 and you go from the bottom to the top, this is just example. But you can say that I have 10 here and 10 here. So this is the longest path. So the diameter of a binary tree gonna be 20, because we have 10 on the left, 10 on the right, which can be like just 5, and then it's gonna be 15. Is it clear? So it's like we're gonna search. It's like we're gonna check. We're gonna launch a DFS. DFS, what's gonna do? It's gonna go to each node and find how many node it have in the left, number left, and how many node it have from the right. Now that's from that. If we figure it out, this one it have what? 1. Let's say 1. This one, how many it have? Let's say the path, the edge, 2. So okay, so 1 plus 2 is 3. So this path like this path is 3. I'm gonna save it in this variable 3. Again, I'm gonna go to 2. I'm gonna count again, left and right, left and right, right 1, 2, 2, 1, 3. I'm gonna see, is 3 bigger than the value I have here? No. Or so I don't need to save it, right? I can keep the tree that exists, and I keep doing the same until I reach 6. Now when I'm gonna reach 6, I'm gonna launch again DFS on 6. It's gonna return left 10, and let's say this is 5. It's gonna return right 5, so 15. So the path here is 15. I'm gonna compare 15 with this variable. Is 15 greater than what I have in this variable? It's gonna be yes. Then I'm gonna put 15 here. When def is finished, I'm gonna just return this, which mean what the value here, it mean, hey, I did find the longest path. Is it still confusing? Who have any question? And this is one of the solution. I'm sure there is more solution. If someone want to suggest another solution, yeah, we can go with it. Okay, who have any question? Do we go with this one? Guess we go with this one. So we need to create a variable, right? That we're gonna keep track of this. So let's call it a result. Okay, let's say at start it's 0. At start it's 0. 0 or 1. I guess 0, but okay, let's keep it 0. That's, we start from 0. Now this is DFS, right? DFS, it means it's a recursion. 0, okay. So recursion, we're gonna always start with the base. So if it is a base, let's say DFS, this is our DFS, and we're gonna give it a node. Now the base is what? We're gonna see when this one stop. If you notice with me, this one stop when we launch left and the right, and there was no node. This node on the left and right doesn't exist. 4 doesn't have any node. So it's like we're gonna say, also we know that when it is doesn't have any node, we return 0. So it's like saying if not node, return 0, which means like when you don't have where this node doesn't exist or equal none, return 0. So now this is our base. Now when we are in the one, if we launch this node in the root, so if I did DFS root, what's gonna happen? I wanted to launch another DFS on this left and this right. So it's gonna be left equal self, or like let's just do DFS on node left, node on the left, and the right gonna be DFS node on the right. Now this gonna launch a DFS on the left, on the right, on the left, and itself because this recursion itself, it's gonna launch on the left, on the right. Now we said this also gonna launch on the left, on the right. Now we need to see return, how the return gonna work. 0 and 0. So this gonna return 0. And this gonna return 0 to this, and this is 0. And then this node gonna see the max between, wait, the max, or yeah, because we set the max with the variable result. So result is gonna have 0. Now our point was like, hey, when I get value from left and the right, I'm gonna do addition, and save it in the variable if it was bigger than the value that was there before. So I keep track with which one is like the bigger path. So I need to do it like max, so result. So the results gonna be the max between the results and left plus right. Right? So the result, now that I get the value of left to the right, I'm gonna save it in the result. If it was bigger than the value that was the result before. If it's not, then it's gonna stay there. This way, going through all this DFS, all this node, I'm gonna always have the max value here. Yes. Simple length calculation, except you keep track of the max sum. Yes. Are we missing something? So we said.
Did you do the max?
Oh, the max. Yes, we're missing the max here. Max. So what's max do in Python? Max, or I think in any language, is like it's gonna compare result value with left plus 1. This value, left plus r. It's gonna compare them, and the bigger of them is what's gonna be here, added to here. So if a result is bigger than left plus r, it's gonna be added or assigned to the variable result. Are we missing something? return, right? Because we want to return this value here. So return result. Wait, did we return here? We didn't return here. So here we should return left and right, right? Return. Wait. We're gonna return. Yes, we're gonna return. So we calculate the height. So we're gonna return left plus right plus 1. The max of them. Max of them. So this is how we calculate the height, right? So why we did this? Why we did this return max left plus r plus 1? Because this def is at some point need to return, right? So for example, this gonna return at this at some point. This gonna return at this at some point. Now, this 4 have 0 plus 0 coming from left, 0 come from right. It's gonna add 1 to it because itself is 1. It's gonna return it to this. So it's gonna return the left, which come in 0, and the right. Let me put this like this. 0 from here, 0 from here, 0 plus 0, the max of it, plus 1. It's gonna return it to here, 1. Why to return 1 is like saying, hey, between me and you, there is one edge. That's exactly what it means. Between me and you, there is one edge. So if you think if you think about it like this, normally this should return to what? It should return 2. So it's gonna say like the longest. So I need to edit that phrase. So the longest path from you is 2. So like saying to 1, hey, from you to the end of the edge, or like to this path is there is 2 edge, and this can return 1. Why do we sum errand left? Okay, so let's say in this case this is return here 1 and 2. Now this max L plus R is like saying the maximum between left and R plus 1. So if this, let's say this was 5 and this is 1, what's the value I want to return is like 1 plus 1, which is 2, or 1 plus 5, which is 6. It should be 6 because it's like saying the longest height. The longest height is what we return. I may be confused a bit. Oh, wait, is that what you're asking? I think you're asking something else. Why do we sum R plus L? I think you're asking about this. Which is this or this? Oh yeah, you're right. This is a typo. It should be a comma. Yes, you're right. Thank you. But this one should be plus. Okay, let me repeat this one more time. Let's repeat the whole algorithm. So the idea was like, okay, I need to figure out what is the longest path in this tree. So the longest path, if we see like with eyes, we know that 1, 2, 3. So going from the node 4 to node 3 it have 3 edge. Going from node 5 to 1 3, it have 5 to from 5 to 3, it have also 3 edge. So the longest path is 3, right? Now how we can calculate the height of like the depth of this node? So I need, if I launch a DFS on this one, I need to calculate this height and this height, and plus when we're comparing the output. So I'm gonna return 2 from this side and 1 from this side, and 2 plus 1 is like the longest path. 2 plus 1 is 3, is the longest path. It is what we did here. We did L plus R, and we save it in the result. So like this, every time I launch a DFS on this node, I can keep track of the longest path. But how this value, we got it from where? And this one from where? We got it from L and R. Now L, it was DFS node left, which means this is the root, and node left of it is 2. So we launch another DFS on the node 2, and which itself it launched another DFS on 4 and 5, and this is like a recursion. So this one did return to this 1, and this one returned to this 1. It's like saying there is one node here, one node here, and this 2, it's gonna return the max of L and R plus 1. So 1 1, max of them plus 1, which is 1 of 1 is 1 plus 1 is 2. It's gonna return 2, and this one gonna return 1. Also, if you find this one hard to like understand or ready to go fast, just like ask your question and try to clear it, or also check, I think binary, no, not binary, I think which one, this PLD, and somewhere one else, I think 3. Like check them out, they're gonna help you understand it more, but this one is better. Okay, who have any question about this algorithm or like this pseudocode? What is not clear? Which line is not clear? What about the results? So at the end we're gonna return results, right? I believe. DFS is like depth first search. Just check it out, and check it out from here, or like check that PLD number 9. We did like go through it in details. Okay, let's see if this gonna work or not. So okay, I need to change many things here. So we're gonna put this function inside so we can still have access to results. And what we're gonna do here? Left, this is gonna be self, right? Self. Mm, if it have one child, that's a good question. What's gonna happen? With this code, what's gonna happen if it was one child? What should report or like return? 1? 0? It should report 0, right? Okay, this root have 1 and 2. It return 1. So if it was have only 1, it should return 0. Because there is no edge. Right?
Yeah,
One child, 1. No child, 0. So I guess it's gonna return 0.
Yes, because there are no edges as you said, so it should be 0.
Okay, is this hair look clear? Not. LR. I think it's clear. Yeah. Oh. Okay. Okay. Why are you laughing at me? What's happening here? Results max. Results L plus R. Oh, self dot result.
No dot left. Yeah.
I think self dot result because it's outside. Is it? Wait, where is it result? Oh, self dot result. Self dot result. Wrong answer. Why? 3, 0. Wait. I think I'm mistaking something here. If not node return 0, if is node left, right?
Okay, you should also do self the result exactly.
I didn't do it here. Okay. Okay, let's submit. Okay, nice work. Okay, 80%, that's good.
Nice one, guys, nice one.
This one was a tricky one to understand. But please, if you have a question, go ahead. I'm sure there's many ways to solve this. This is not the only solution. This person said worst solution ever. Worst? Let me check it, I'm curious. Oh my god. Really? Wow.
The comment was in there. The comment was there for a reason.
Yeah. Okay. Once you start writing this in interview, you are no longer in danger. You are the danger. Big omega time complexity. Thanos had to snap twice to wipe out this code. This is beautiful. How you thought of this abomination? I have no idea. Okay. That's funny. That's cool.
But probably Mohammed would have done it that way.
Is
it Mohammed or Mahmoud?
Mahmoud? No, Mahmoud will do it really short. We miss Mahmoud. Where is he? Is he here? Yeah, we miss him. Okay, that was today. Let's code. Please, if you have like, if something not clear, just send me DM or like go back watch recording or the other PLDs that we did. I hope you guys feel more comfortable with LeetCode and you feel brave to solve some. That's it. Have a good night. Hope you guys.
Thank you. Sorry, Nox, I have just
Yes,
one
go ahead,
question.
please.
For programming languages that don't have like the DFS function.
Oh no, this is not. It's not we can call it like what's your name, Metiti? I can call it Metiti, right? It's just a name. I give it to it. It's not a built-in function. The DFS is like, think of it as a recursion function that we call it inside itself, right?
Okay.
And yeah, like if you go back to this PLD number 9, you will understand what's DFS and what is BFS.
Okay, thank you so much.
Thank you too. Okay, have a good night. Thank you. Good night, everyone.
Good night. Thank you.